But I want to go ahead and actually share this forum post from a little icon that some of you may recognize, Hugo, Code Monkey. He actually had sent me over this kind of issue that he had brought up, or that he had kind of discovered as he was kind of diving back into dots. And I think this forum post does a really good job about just like highlighting a couple, misconceptions that people may have, especially as they're starting to get into dots. And then further down the forum thread, there's actually a couple other really interesting topics that get a little bit more advanced on a couple of things here. So anyways, the root of the issue, basically what Hugo was noticing is that he's using an iJob entity with a .schedule parallel. And he's saying, as far as I know, this should split the job to run on multiple threads, but it's not doing that. It's only running on a single thread. So you can see here what he has is just this simple rotating cube job. And it's going to go ahead and, rotate everything with these proper components and everything like that. And then he also had just kind of some like extra logic in here just to like make this, whole section of code just be more efficient than necessary. So it would be a little inefficient than necessary. So it would be more obvious in the profiler here on some things. And it's funny because later on, he actually enabled burst, and burst basically just removed all of this code here. So so basically all it was doing is just the actual rotation part, whereas doing something and not just doing some calculation that doesn't really do anything. Going through, here's kind of a look at his profiler, and you can see that he has a bunch of idle worker threads, and he has this rotating cube job just kind of going here. So the reason that he was experiencing this is because he was only testing this against, I think, about 200 entities. Now, what's ended up happening is because 200 entities, that's probably going to fit into two chunks, because one chunk is a pre-allocated block of memory, which is 16 kilobytes in size, and that's where all like the entity data is stored. Now, chunks can have a maximum of 128 entities. So, just having a couple lightweight entities, these were probably separated across two chunks. And the reason I'm bringing up these chunks is because when you do this iJob entity and it, updates the local transform on all these entities, each worker thread is running on a per chunk basis rather than a per entity basis. And that has kind of a lot to do with like just how the memory efficiency works of Unity ECS, because if everything is in one chunk of memory and then you have one worker thread kind of pull that chunk of memory into the cache and everything like that, then it can just easily iterate through all those entities in that one particular chunk. So it actually is kind of an efficiency gain, even though we're not rotating everything across all the different worker threads. We're just kind of operating on one chunk of memory at a time. So it's really kind of about managing memory in that case. So they kind of brought it up. So talk about 200 entities, 128 entities per chunk. I did kind of highlight this here as a little teaser on some things that we're going to see later on when we talk a little bit more in depth about the transform system here. But then he said, yep, that does appear to be correct. When he increased this to 1,000 entities, then now we start seeing the rotate cube job go across multiple worker threads and everything like that. So again, that's kind of the main solution there, the main reason that he was seeing that. But then going on, this goes into a little bit more of the kind of deeper related topics. And so someone says, what can I do if I've got some long-running operations on a few entities inside one chunk and I want it to be performed on multiple worker threads? So there did actually used to be this iJob entity batch, and there was a schedule granularity option where you could actually run jobs on a per entity or a per chunk basis. You could kind of differentiate between the two. That is no longer a feature, and we can maybe again, I think kind of the main reason is because with the iJob entities and everything like that, like I was mentioning with the memory efficiency, we prefer to be operating on one chunk at a time. But there are ways, other ways that we can do it on a per entity basis if we want to. I wanted to bring this up before moving on because I just wanted to ask you, Tobias, had you ever used like any of the schedule granularity stuff for any jobs that you had been working on where maybe you wanted things to be parallelized on a per entity basis?
No, I didn't actually know until this forum pointed that out. But I can say that I sort of hacked around it by disabling a bunch of the safety features and then just scheduling one job manually at a time for every entity. So there is ways to and get around it, but by with still having the safety system fully engaged, I think this is probably the best way.
Right, right. And yeah, so I did want to mention here. So Turtle says that you can create a list of entities using to entity list async and then pass them into an iJob parallel for defer and set the inner loop batch count to one if you want one entity per worker. So there is kind of, some ways that you can get around that where you would create more of like a manual job as opposed to the iJob entity where, it does kind of some code generation stuff for you. It's just not possible with how the current setup is used to do a one entity per worker thread scheduling. But again, you can use just kind of like some of the things built off of regular jobs to actually get that granularity if you need it.
All right.
Yeah, and then so I also kind of wanted to bring up the concept of longer running jobs because when you kind of like initially think of like hear of like what the job system is and everything like that, like you're able to kind of like parallelize work and all that. One of the things that your mind kind of maybe goes to is like maybe having longer running jobs where you have some like really complex calculation that could take potentially maybe even a couple seconds longer, longer than a couple frames. And you start thinking like, oh, maybe that's kind of like a way that I could kind of use the job system, although that's not necessarily the best thing to do for many reasons that we could get into. But kind of wanted to bring this up. Like, Tobias, have you kind of considered using longer running jobs or looked at some alternatives for some things like that?
Yeah, I have a longer job in running jobs in my game, but it's in a different context. It's not when the game is 60 FPS. It's when I generate my world. I have a
Mm,
few jobs that are kind of slow, and the runs maybe for I don't know 300-400 milliseconds, something like that. But that's a different situation. I never, yeah, that situation of like letting it run through different several frames in the background.
right.
I don't think I have anything like that.
Yeah, yeah. And I kind of just want to bring up like maybe some of the issues with that are, especially when you're working with entity data and you say schedule a job that, could run, many frames long, there could be a difference between the entities that it was scheduled on at the beginning of that job and the end of that job. So, maybe if you're saying run this job on these entities, well, that runs across 10 frames. Well, that entity might have gotten destroyed by the end of that. And so that could kind of lead to some weird issues. And then also, if you're working with entity data, one of the things that Turtle brings up here as well is that you'd probably have to do some double buffering on your data. So essentially, you have kind of like the live data that like all your other systems are kind of like dealing with and interacting with. But then you also have like a copy of that data component. So you have like another data component that kind of longer running job is kind of like modifying in real time so it doesn't like affect all the other systems. And then once that's complete, then you could kind of push that data to your main live data, if that makes sense.
Yeah, I was going to say that I think most of the situation where this would be reasonable is when the data you're working with is not really, well, it is connected to the ECS world, but it's still like more or less like, yeah, you just have an isolated piece of data and you put it in some buffers or some arrays or whatever, and you like go on maybe like pathfinding or something. You don't really
Right.
need to know
Yeah. Yeah.
much about the world currently because pathfinding is something that could be take half a second and nobody would care.
Right.
Yeah,
Yeah.
yeah,
And again, yeah, you're not just limited to using jobs. You of course can use like, asynchronous methods to do things like this where it, still would kind of end up getting pushed off to a different thread. But again, maybe you're not working directly with that entity data, so you wouldn't have some of those similar problems. You still kind of would have to do probably some sort of essentially double buffering thing where you're, copying some data over, running a long asynchronous work on that, and then bringing it back over into the entity side at some point.